here's something you don't know about me, I'll bet. But I am in the Guinness Book of Records, the Gamers Edition, because of my study, my brain imaging study of Tetris. And I did a brain imaging study of Tetris. I think it was published in 1992. I really wanted to do a study of learning. I wanted to see what happened in the brain before and after you learned something.
Yeah.
And back in 1991, when I was doing this, nobody had personal computers. Nobody had ever heard of Tetris. Computer games were not what they are today.
Right.
And I went to the Egghead software store when they had software stores. It had just opened. And I was talking to the guys there about, I needed something where I could study before and after they learned something relatively simple.
Yep.
They showed me this game Tetris. It had just come in. They just had opened the box. They put it up on the computer there. And I thought, boy, this is really perfect. It's simple to learn, but there's an enormous learning curve. And we brought in college students, a small number of college students, and we showed them how to play Tetris. They practiced for a few minutes. We injected the radioactive glucose for positron emission tomography, and we did PET scan studies of them that very first day they played Tetris for 32 minutes. They then practiced every day. They had to come to my office because nobody had a PC at home. They came to my office 5 days a week for about 4 weeks. They practiced until they got so good at Tetris. You know, the game was moving faster.
Yeah, it's amazing how good people can get at that sort of thing.
You couldn't even believe a human being could do this.
Yeah, I know. I've watched people do that sort of thing. It's just absolutely unbelievable how good they can get at it.
Right, and when they got really good, we scanned them a second time.
Yeah.
And we found that even though the game was faster and harder, when they had learned how to do it, they used less glucose metabolic rate.
Okay, so now, was that also, okay, so I knew that research. I read that research. Now, what do you think about the problem is I can't remember where this research came from, because I also read at approximately the same time studies that appeared to claim, and I think this was reviewed by L. Conan Goldberg in his book on hemispheric specialization for routinization and novelty, respectively, that when you first start to learn something novel, and I think this was demonstrated, for example, in people who were listening, they were Danish native speakers who were listening to Danish in reverse. And they used very large portions of their brain when they were listening to Danish in reverse. But if they were listening to Danish properly spoken, they used very small specified parts of the brain that were located in the latter or in the back part of the left hemisphere. And there was another group of researchers who were demonstrating that as you learned, the degree of activation decreased, and it shifted from the right to the left, and it shifted from the front to the back, and it got smaller and smaller. And is that associated with that decreased glucose utilization? Is that the same phenomena?
I think it is. I think we were the first to show it.
Yeah.
We had done one imaging study before this Tetris study where we just correlated glucose metabolic rate with scores on a test of abstract reasoning, a high G-loaded test called Ravens. They had taken the test during the imaging, so we got to see what brain areas were involved, and we did find some brain areas, but the really interesting, surprising thing was the correlation between the scores and glucose metabolic rate was always negative. The better they did on the test, the lower their glucose metabolic rate. And that was the first inkling we had about this idea of brain efficiency.
Right.
Subsequently, there's been a lot of research on that. And it turns out to be a complicated thing because nothing about the brain is simple.
Right.
But
it does seem to make perfect sense that expert skill is associated with doing more with less.
It makes sense now. But I tell you, nobody predicted it. And
I understand. That research stood out for me in a very striking manner. So,
but it also gets at this thing about that you raised about practicing on different kinds of tests. Because one of the attractive things about Tetris is its visual spatial, its planning ahead, its attention. There are a lot of elemental cognitive tasks necessary, it's fine motor control, really necessary to do well on Tetris and to learn it really well. And so the Tetris company found my research some years later and asked if I'd be willing to try to replicate it with more modern imaging, which of course I was willing to do. And so they funded this. And we found now instead of PET scanning, we use functional MRI and structural MRI both. And we did find, like we found with the PET scanning, there were areas where after teenage girls with very limited gaming experience learned Tetris, their brain activity decreased. But we also found from the structural MRI that there were increases in gray matter. And the really interesting thing is the areas where there were increases in gray matter did not overlap at all with the areas that functionally decreased. It would have been a terrific story.
Wow. That's strange. Yeah, well, things are always more complicated than you hope them to be.
Not only that, but I can tell you that every time I did a brain imaging study, we always found the exact opposite of what we expected. Not
well,
just
that sounds to me like, you might actually be operating as a real scientist. Because, I mean, things are so damn complicated that it's really difficult to guess right to begin with.
Well, it led to one of my 3 laws that I based the book on. Law number 1 is no story about the brain is simple. Law number 2 is no one study is definitive. And law number 3 is it takes a long time to sort out all the various studies to see what's consistent and what establishes a reliable weight of evidence.